Yo! What's up? Welcome once again in what might be the last episode of the Mars Rover Kata. Tonight we are going to try and make our rover detect and warn us about obstacles when we pass it along some commands. What we did before, last night we implemented wrapping across maps edges. And before that, we implemented basic commands. So we'll just first start off with checking out what our rover currently looks like. A rover can have a direction, a position, and it's on some kind of planet. Then it can receive some commands. When executing such a command, it can be either a move command or a rotate command. And when moving, I think we actually, this can go because we already did that refactoring last night. So by the way, if there's any tip that you have for me, just let me know. It might be something like, hey man, your mic is not working. Please tell me. I had that happen last night when I was chatting for about 20 minutes when my girlfriend called, and then only then noticed that I had myself muted all the while. So feel free to type in chat. By the way, if you want to check out the code, I'll leave a link in chat. And I think this should be it. Let's see if that is indeed correct. Kotlin. Yep. All right. So I pushed all of my changes to the LiveCoding 2 branch. And then you can follow along with the code that I have. If it's too confusing for you or something, I don't know. Or you just want to code along. Cool. So here we go. Let's try and do this then. So moving and then rotating is fairly easy. And then wrapping, I delegated to the planet. That's basically it. So as usual, we can start off by, maybe I can show this as well. So these are all of the tests I've got right now. Yeah. So these basically deal with moving, I think. No, also rotating. It should be a little bit more organized, I think. Or it could be, let's see. And then I also have one scenario test where I just passed it a bunch of commands. And then check the final state, basically. So I think what I want to do is I want to make a new test. Well, actually, let's first rewrite this so it could also be read properly. A rover receives a bunch of commands. And we check its end state. That's basically this test. And now a rover receives a bunch of commands, of which the middle one or something, at least not the start or the end, the middle one would cause the rover to crash into an obstacle. So this scenario is what we're going to try to do tonight. So let's see, if we just pass it along, we'll just keep it simple, I guess. Pass it forwards 5 times or something. And then on this forwards, the third one, we'll put an obstacle there, and we can check whether or not the rover has crashed, basically. So the direction that it's facing should remain north. Oh, actually, it might wrap already or not. No. So let's just check. This is the initial position. Then we receive forwards once, forwards 2 times, and then forwards a 3rd time. Or we would receive it a 3rd time. So this would be the end state. And then I need to put an obstacle position. That would be this one. On 3. I really need to take care because I think Mars, which is the default planet, is a 5x5 planet. And I think, yeah, so 2 would be an edge. Ooh, that's an even better test then. Well, actually, it's not a better test then because, oh yeah, no, it's a great test. Oh. We'll put an obstacle at -2, so on the wrapped edge, and then this third forwards command would wrap the rover, but instead it should stay there because otherwise it would bump into this obstacle. Cool. So this is really what we want to do for today, and then also I think checking whether or not there is a message. Message, maybe. How do you want to do that? Maybe like this for now. And our message should read, there is an obstacle at, and then 0 - 2, ignoring further commands. Do not want to do that. So let's make another message. It can be a string and it can be optional as well. And then we'll set it to null. I think this is default, actually. I'm not really sure. And then this test should actually fail. Because I expect, currently it's gonna be at position 0 - 2, normally, yeah? Oh, it didn't move yet. That's very strange. That's weird, no? Well, it's definitely on Mars, it's facing north. But then the actual is back at 0. Kinda weird, no? How does that work? Well, for this, my friends, we wrote a debug command yesterday that should show us what happens when our rover actually, yeah, of course, it just adds 2 more forwards as commands, and then also executes that. So it would be 1, 2, then it's on the edge, then there's 3 more, so 1 to wrap around the edge, which makes it at -2, and then 2 more, -1, and then 0. So these are, well, actually these are the culprits. Culprits, huh? Rover, let's disable this debug thing. Also, I'd like to know, like, I wrote this because what I actually wanted to do was this. So I wanted to, you know, in Elm, you can go like this, and then you just pipe a command to the log function, which then also just returns it. It logs and it returns. And that's basically what my debug function is doing right now. Right. So our test is failing right now. And now we could, well, our planet needs some setup as well. Because we need to make sure that this obstacle is somewhere on the planet. So I'm gonna guess that our planet now will have random obstacles somewhere, but not really random because we really want to do this. Thanks, Kun. Cool debug function. And maybe I should just show the output. So in our scenario test, we could just see that it's whatever command happens and then whatever state was in between. So it will receive a forwards command and then the state will be 1, then 2, then wraparound. We've got a wraparound. And then it just continues going on forwards, going north. That is, so that was that. We were actually giving this obstacle position to, you know what? We can go like this in a while. But first, let's just keep it in a position and then pass it to a planet. Let's make Mars again. So now Mars is a planet that's constructed with a 5x5, but which doesn't have any obstacles. So maybe we should give it fixed obstacles for now. Yeah, let's do that. Let's give it some fixed obstacles. Yo. I think it was at 0, -2, right? And then let's keep it at that. This one, empty list, is that a thing? Yeah, of course it is. And then we'll also pass along a private value of obstacle positions, which is currently a list of positions then, and which is by default empty. That's more neat. Then I can go like that. Cool. Oh, let's also put that on a new line. Now Mars has some obstacles. Then we don't need to define this, but it'll make our test a little less readable. Because we sort of expect Mars to have an obstacle. Yeah, I don't like that actually. Yeah. Let's get rid of that stuff then. I think what we could do is have obstacle positions initialized late so that you can pass along positions to it at a later time instead of at construction time. The reason why I want to do that is because I want to make sure that a planet only has odd numbers for sizes or for dimensions because there is no real middle and I need the middle for my edge functions for these. Now I could build this properly, I guess, but yesterday I didn't feel like it, and today I don't feel like it either. So what I'm going to do instead, and also it's going to give me some practice. Here's my excuse: it's going to give me some practice to practice with late initialization fields, especially because I have no idea how you actually do that. I think there's something like this, and then it needs to be a variable, of course. Yeah, like that. Then my Mars planet doesn't need this anymore. I can pass it a late init, no? Is not allowed on properties with initializer. Yeah, it's time to look at the docs, yo. Allee. Ooh, now we can also even see that the chat feature is working. Hooray! Late initialization. There's something about that, right? Basic, or maybe classes, properties and fields. Late init. Yeah, there we go. Okay. Properties declared as having a non-null type must be initialized in the constructor, right? However, fairly often this is not convenient. Okay. You cannot supply a non-null initializer in the constructor, but you still want to avoid null checks when referencing the property inside of the body of a class. That sounds like the stuff that we actually want to do. I think there's also some special stuff with delegated properties. Let's open that tab as well. And then actually figure out what is going on with this bit. Maybe it's not allowed on properties. Ah, yeah, because I'm so dumb. There you go. Then I think we'll need a constructor, which then also takes a dimension, I believe. No? I really want to do this. I just want to do this. Set the default. Ah, yeah, and I think constructor needs to be... It's just a keyword that you can put in front of this. But you can omit it because it's, you know, more concise that way. This saying it's not used yet, but can we actually set it? I didn't make it private, so maybe I can. Just kind of weird because I only want to set it up at construction time. I mean, I don't want obstacles to randomly change whenever, right? Only maybe on certain events or something. Alright, so let's extract this planet Mars. And then see if we can... Oh, we can actually. There we go. And then, since it won't be initialized yet, because to add stuff to a list, you could do like this, but our list is null. So I'm going to just go like that and pass it along the obstacle position. There we go. I think I've got another idea. Can we go like this, where Mars only has a list of obstacles? Problem? Ah, yeah. Then we'll make this into a class, I guess. And then what we can do, maybe, is... Oh boy, how do you do that? I basically want to guard this constructor and then pass along the obstacles that Mars knows about at a later time. Can you go like that? Obstacles. Something like that, maybe? Maybe. Yeah, I know too little about Kotlin to actually do this properly. Yeah. Phew! And I'm also super hot. Let's put that aside. There we go. It's cooler already. No, maybe overriding properties? It could be something. Ah. So it's what we had before. Override our obstacle position, no? Is that because it's not a... Oh, backle. What about now? Ah, it's final. What do you mean it's still final? Kind of weird. Yeah, I could use some hints. I keep alt-tabbing and then my browser on my MacBook is opening up constantly. It's annoying. You can also override a val property with a var property. Was I not doing that then? Is it? Yeah, no. It doesn't need to be open, right? Oh, it does need to be open. Ah, yeah! Final is also something that open covers. Simplest test right now is always to have an obstacle at 0, 0. Well, that would be a great idea if my default rover position wouldn't be 0, 0. So I would spawn it inside of an obstacles. But yeah, something like 1 and 0, that would be good. Because what was I trying to do? I really just wanted to do this. It's something that I wanted to get. I tried doing that, right? So I said, maybe I can just initialize Mars with an obstacle at, what was it again, 0, -2. But then it would make this test way too implicit. And I favored the explicitness. But I understand that you want to continue doing something useful. Because I want to do it myself as well. But let's see where this gets us now, because it seems to be compiling. So maybe now I can actually create Mars with a list of obstacles. There we go. Yay! This seems legit. Now I hope it works. This shouldn't fix anything. Because we're... Oh, some compilation errors. Ah, right. Okay. And so now Mars does require... let's just do it with an empty list here. Ah, wait. Can I actually set the default to an empty list here as well, maybe? And then I don't need to pass anything? Oh yeah, it still needs to be constructed. Okay. Seems legit. What about the rest? Is it still compiling? That is a negative. Okay, so an empty Mars should be on the planet Mars without any obstacles. And then I think that's the last compilation error we have. Hopefully. Yeah. Then let's run all of the tests. All of the tests are failing. Why is that? Because it's a different... Oh no. It is a different instance, of course. Yeah. I don't know if you can do that. Oh, you can. Okay, cool, nice. So data classes automatically provide an equals and hash code implementation. But I think they also make these things modifiable, and I do not want that. So let's run this again, and now it should actually work. Okay, good. So our test is indeed failing. Yay! Cool. Okay, cool. I think that's that actually. Yeah. And now we can check for obstacles somewhere in the move command. So here is move. The thing we first tried to do is check what the moving direction is. Why is that? Because of the combination of forwards or backwards, and then the facing direction should either flip or not flip the facing direction. You shouldn't flip the actual facing direction, but it has an impact on the moving direction. That's what's expressed here. So when it is when this is for example forwards, just keep facing direction. When my move command is backwards, then flip the facing direction. Then we've got our moving direction. With that, we try to move to new position because this isn't actually moving. This is just getting like the new position basically in how do you call that? Like this doesn't take into account wrapping or obstacles in this case. Wrapping we did like this. So I guess what we're gonna do is like do is an obstacle position or something like that. Now the tricky part will be that we also need to interrupt the rest of the commands. But at least we will make sure that there is a warning or something. So what we could do is check for obstacles or something. At wrapped position, which should return a position or not. So we'll do it like this. Create this function. This is a position, not necessarily a wrapped position. And then the thing that this should do is check the planet and then whether or not there is an obstacle there. Now, I do notice that we only have one scenario test for this thing now, currently. And what I really want to do first is create an actual test for that. So a rover well, the rover doesn't really matter upon a rover on having an obstacle right in front of it when receiving, or it's upon receiving, I think. Upon receiving forwards, should report the obstacle's position. What does that stuff look like? Just call it a rover. I don't care about the direction that it's facing. Actually, I do care. It should be north, right? Position should be fine, but then planet, very important. It should be a Mars, and it should be a Mars with a list of position at 0, 1. That's right. A moved rover, I guess? Or actual, let's call it actual. A rover should receive a forwards command. And then we can assert that actuals message, I guess, is equal to the thing I wrote in the other test. Oh, Mabi. And then 0, 1. And then this should fail as well. And then what we could do next is write tests for moving backwards and in all the wind directions, basically. Let's make a note of that. Wind or other direction tests plus backwards. Okay, cool. And then this test is failing, but then yeah, it's failing because we've got a to-do not implemented. Guess now everything is failing. Yeah, for now, I think it's a bit silly since I'm testing for a message. I guess this should return a string instead of a position. Because it's the message that I'm checking, right? So let's also pass along the message and then have that be the message. Cool. How do we do that? If planet has obstacle at, I guess, a position. This is kind of weird, eh? Because our rover asks the planet, "Hey, man, do you have an obstacle there?" I guess we can rename this to "Look at," or this should be. This is actually "Look at." Okay. Anyway, we'll return obstacle at. Let's create a function containing. Yeah, this is it. Now I want to put these with all of the public functions, so let's put it up here. Turn false, I guess. Then create a test for this one. Tests has obstacle at. Given position is an obstacle position. Should return true. And given a position is not, should return false. So the is or is not is a kind of weird because we know our implementation is that a planet has a list of, and I'd like this to read something differently, right? I'm gonna be like given the given position is not an obstacle, maybe. It's already a little bit better. Cool, let's do that. Unless you tell me to do it otherwise. Let's create all of these so planet with obstacles. Let's just build Mars, which can contain obstacles. Position of 0, 0. And then when we ask has obstacle at position 0, 0. Is true. And then we'll ask a different. And then another thing we could do. And just tell me if you like this or not, or if I should make another test for this, okay? So there's it could go. I need to. Okay, what I wanted to do is this. So planet has no obstacles. Then the given position doesn't matter. So we'll explicitly pass along an empty list of obstacles. This should be false, and then this one should actually also be false. Let's run them all, baby! And have a sip of my Coke. My bad. Return null. rerun the test. Expected to be true, expected null, actual null. What? See, I think this is so weird, but I think it's because of... Wait, what's... Am I not using the... Yeah, I am. Should be fine. So this is the only one that's failing currently. The rest, yeah, of course, default returns true. Now some list functions, I guess. How do you do that in contains? Molly. What if it's empty? Well, it doesn't say. Well, good thing we have a test then, I guess. Still works, because an empty list doesn't contain a position. Cool. So that's that. Then we can actually use that function now. Unless I'm forgetting something and I'm kind of on you guys to tell me if I did indeed forget something. So if it has a function, yeah, then we should return that message that I keep forgetting because it's too long to remember. Return this stuff. And otherwise, return null. The only thing I want to check actually is that it's at 0, 1. How do you do that? A position to string. I don't have that thing yet. So let's build it. Yeah. Create a test. As a string. Do I really want to? I don't. This will be super clear based on my test content. Position 1, 0 as string is equal to 1, 0. Oh, maybe don't forget the braces. Ah, yeah. And then this should be like this, and then we need to actually make it into a string. There we go. And then some minus numbers, maybe. Minus. There we go. This test should fail. Well, it's not compiling, then it's failing, I guess. Actual blank. Yeah, makes sense. Great. Make the first test work. Oh shit. Make the first test work. Rerun it. Yeah, great. Now we can go like this. So it should be like that. A comma in between x value, y value. Remove curly braces. Ooh. Ooh, Kotlin. You so concise. Ooh. This is great. Right. Now let's get back to our rover, where we are now using this. Can you... these braces you can't remove? Yeah. because we're calling a method. What's IntelliJ's suggestion here? Lift return out of. Yeah, let's do that. That's nice. And then let's just for. Oh no. Okay, this one. This one doesn't look much prettier actually. Yeah. Okay, getting back to our rover test now. And I think this one should work now. Sweet. Let's write these tests too. So a rover having an obstacle right behind it. Upon receiving backwards then. Should also report the obstacle's position. Let's put it at -1. Backwards. And then there should be an obstacle at -1, right? By the way, if you're curious what the music is I'm playing, this happens to be the music from the game Astroneer, which is a game where you can run around on a little rover. I thought it was appropriate. Alright, what is the next one? So that was backwards. Yeah, and then the other directions. Now you can already see this explode in combinatorial ways. Actually, you don't need the other tests because on rotating, maybe let's write that. A rover upon receiving a rotate command should not report the obstacle's position, right? So then we'll put our rover, for making sense, let's say that our rover is facing to east, and then we'll pass it a left command so that I want to mimic that it rotates north and then sees the object in front of it, and then it shouldn't report anything. And we know that this is gonna work, right? And then the other tests are already, or not. Annie, we don't have a test yet where a rover moves with or on a planet that has obstacles. So let's, yeah, we need that for both forwards and backwards. Whoa. An obstacle having, or a rover having an obstacle behind it, maybe. Upon receiving forwards should not report the obstacle's position. So we'll put an obstacle behind it. Pass along forwards and then is null. Then an obstacle, what, right behind it. So right in front of it, upon receiving backwards, should not report. Like this, and is null. Alright, now I think our tests are complete, unless you can correct me. Seems legit. I feel, wait, I was gonna say I feel like I want to commit now. We've got still this thing that's failing. Why is that? Another thing we are not doing yet is clearing messages, but then it's kind of a weird thing to do. Wait, what? Ah, yeah. So this definitely should also be on Mars because we don't want to have it teleport to a different planet of Mars that doesn't have any obstacles. Okay, so that's that. Now the position is the only thing that's different. Why is it again that I expect it to be at... Ah yeah, I expect it to stop there and then instead it's continuing. However, I expected the message not to be null. I do overwrite it, don't I? Yeah, I overwrite it when I move forwards. So the first time, well, actually the time that it comes across it, it sees it, it reports it, but it moves in that position and then it explodes basically, right? And then we do not have a rover anymore. But then again, this is a scenario test, right? So, and I only have implemented reporting messages yet. So this thing deals with the second part, which we are about to implement. But I first want to make a commit, because look at all the files we changed. Jesus. What did we do here? Ah, yeah. We introduced that a planet now can have obstacle positions. Then we said Mars's constructor can take in a list of obstacles. I keep forgetting why it's only Mars that has obstacles and the moon doesn't. I don't know. Oh yeah, we also implemented has obstacle at, because we just want to be delegating. Then the string implementation on position introduced no property called message, which for now is only used as return messages. Right? Then what is this? Check for obstacle. But yeah, so this is the implementation, right? Some formatting tests to go along with has obstacle, with the string, some unused imports, and then the extra scenario test. Added without Mars, more tests, and that's it. Okay, cool. So what we did now was when a rover comes across an obstacle, it reports it. Ba-bam. Dag Koen. Thanks for watching, man. And also chatting. Right, so the thing we have now is a bunch of tests, actually, yeah. Oh. Or a rover having an obstacle. Can Can you go like, I feel like I want to like group them somehow, you know, like sweet or something. No. I'll have to look into that at a later time. Where do I write that stuff down? Ah. Look into grouping test methods. Because then I feel like I can easily have behavior-driven development style tests or test methods. Because it all belongs to a rover. No, for now at least. But I still want to group them all because look at this. Okay, anyway, let's continue writing a new test so that our rover, we can reuse some of the setup. So a rover trying to, or nay, having an obstacle right in front of it upon receiving a move, well, upon receiving forwards, should not move. Well, actually should ignore the command. This is what I want to test, right? Okay. A rover with an obstacle in front of it. That's this. I want to move forwards. Forwards, and then its position should remain unchanged. Let's make that more explicit by also passing along, passing along a position. There we go. This should fail because our rover happily continues strolling into the obstacle. Might be a monster, might be an alien, just running over aliens. We don't want that happening. Cool. So that's that one, and then you can imagine we're also gonna write tests for moving backwards, etc. There we go. So this is why I wanted to return a position earlier. Yeah. You know what? I actually am going to return a position, and then because if we can consider this a function for only checking obstacles, then it should report back the position of the obstacle, whether or not there is one, and then this is like building the message. Because what I could do, yeah, actually it doesn't really matter, does it? Wrapped position. Now let's do this. If message Anne, see, this is why I wanted to do that. Actually, I want to do the other way around that. Nee. This should be obstacle position. So we are refactoring now. This should be a position. So if there is a position, or sorry, if there is an obstacle, we want to return a position. Otherwise, return null. Then if there is an obstacle position, yeah, you don't want to do that. It's if there is no obstacle position instead of this thing. I could flip it into if there is no obstacle, but that doesn't make any sense. Revert. Okay, so let's just write it ugly first. If there is a message, how do you do that actually? Can you go like... Let's go like this. And then IntelliJ will tell us how to make it better. Then actual position. Let's make that into this. If there is nothing, let's just initialize it to current position, so just position. If message is not null, don't do anything. Do this, and then else actual position equals wrapped position, and then pass along actual position. Okay, here we go. So it works. Yeah. Yeah, let's go like that. I don't want to do this. This is ugly AF, man. What I want to be returning is a position. I want to make it explicit that this can return a position. That's the only thing I wanted to do. Can you help me out, please? I'm out of ideas. I only know that it's not proper. It doesn't look very good, and it's like this is now a mutable thing, and what I really want to do is go through the sequence of checking stuff, you know, like I want to first apply this, then apply that, then apply that, and then these in sequence return the actual position. That's the thing I want to do, right? This comment feels unnecessary. this also, we use it twice, so let's keep it that way. This should go. Oh yeah, and then I want function composition. Because you see, I pass along this one into that, then this is being output, and then this output is then fed back into this method, which should return final position. And then final position should in any case be passed along there. Then that means that this is going to have two functions now. It could set the message like this. Or not. Yeah. Yeah, so then I need to return an obstacle with a message or something. Ooh. Ja, nee. I know what I'm going to do. Okay. Okay, I've got it. I've got it, you guys. This. Let's go to planet, I think. And then also make these into planet obstacle positions. Then let's make a type alias. For position. Yeah, nee, but because an obstacle position will always be a position, I think. We could check that for some tests. So what I'll try and explain what I wanted to do, and then we'll figure out Kotlin semantics later. It actually doesn't compile. Okay, so that's actually nice. Dang it! Ah no, it's If it's there, then use that. Otherwise, use the wrapped position. Yeah, okay, that works. Put that stuff on the same line because otherwise it might be a bit confusing. So planet should always be retained. There we do not have teleportation technology yet. So then if it has, then return this. Otherwise, return null. Then what we can also do is message for and then we'll call this obstacle position. Or just do it like this, obstacle position. Then create this function. This is great. And then the only thing we need to do, okay, I already know, is this. I want to return when obstacle position, and then there's a, I forget how to do that. I think is it let or something? Let. Or just go like this. Let. With this value as its argument and returns its result. So basically it's a map function. So it, oh yeah, you go like this. And then this is it. Nee? What you talking about, Willis? Yeah. So only do that if it's there, dude. Ah, there you go. And otherwise it'll return null. Oh man, sweet. So now in Kotlin, any type is a maybe type. And you can do stuff like this, which is amazing. What does this do? Don't want to do that. Move lambda argument into parentheses. I don't really want to do that either. Specify explicit. I don't want to do that either. There you go. The hell am I listening to now? This is no longer Astroneer. Stellaris. Meh. It's also fitting, I guess. Let's go. Yeah, no, this is what I actually wanted to do. Because now both the message stuff works, and then not moving also should work. So let's run the tests. Did I actually check that it failed? I think I did, right? It's still moving. There must be some something wrong with my logic. Something wrong. So let's see if there is a yeah. So if there is an obstacle, return that. Otherwise, so you don't want to do that. We want to do the other way around. So if there is no obstacle position, then return this. How do you do that? Can you just flip it? Can you flip it here? I'm missing some obvious stuff here. I can feel it in my guts. Maybe that's the broccoli. Check for obstacle. It's kind of silly that this planet doesn't do that, right? But that will get me distracted. I want to fix something else first, right? First make it work, then make it pretty. This music, dude, so epic. Actually, now that I look at it, planet and facing direction never change. with move commands. Okay, let's just do it like this then. If there was an obstacle position, return this, else return obstacle position. That doesn't make any sense either. Oh nee, this is just plain wrong. That's why. Remain. This is it. I think in that case I can rewrite it properly. Because now I am just mapping obstacle position to a wrapped or a regular or the original position. So I can write it like this: obstacle position let. Nee, I can't. Otherwise it will still return null. What does apply do instead? No. Okay. Hang on. Alright, good thing to see that the stream is still intact. And I am indeed speaking, and stuff is coming. Yeah, okay, cool. We're learning. We're learning. Sorry for that interruption. Right, a bunch of tests were failing, weren't they? Why was that? It seems that our rover isn't moving anymore. And that all started happening final position. So, if there is indeed an obstacle, yeah, then you need to stay put. Just needed to be flipped. And there's, can you do like this? Nee? Okay, whatever. Yay! What about the rest of my tests? Still working? Okay. Wait, why? Why is the message null? I don't understand that. That scenario test is wrong, by the way. So my rover would keep on bumping, or like trying to keep on going forwards, but it should really interrupt after the first trying to go forwards on the obstacle. But then the message is still being reset. And that I don't understand. Because the obstacle remains there. No? Let's deal with that a little bit later, and let's move this into as obstacle add, so that this thing no longer just returns a boolean, but just returns the position. This is what I want it to look like. Then that is something I don't want to do. This should return an obstacle position question mark. So if there is indeed a position or an obstacle at that position, then we'll return the position itself. Otherwise, return null. Should have fixed the tests first. And here it should be is null. Position. Let's see. Cool. The rest of the tests still working? Yep. Okay, let's commit because once again, big list of things. We introduced obstacle position. Then changed around based on what we produce the message, and now we're mapping an obstacle position to a message or null. A little refactoring, and then that a rover should stay put. Nah, that should be better. Should stay put. Okay, cool. When a rover comes across an obstacle, it stays put. Well, actually not comes across. Would hit, run into, it stays put instead. Plus strings. Okie dokie. There you go. Should stay put. Now. No. I don't want to, like, the what's it called again? The actual assignment. Let's get that thing in here as well. So if you look up Mars Rover Kata and you end up at the Kata log, this thing says implement obstacle detection before each move to a new square. If a given sequence of commands encounters an obstacle, aka would encounter an obstacle, the rover moves up to the last possible point and then aborts the sequence and reports the obstacle. So even when it would be forwards and then backwards, it wouldn't execute the backwards, is what I'm reading here, right? Let me know in chat if you are thinking the same. So that would mean then backwards should also stay put. And this is, yeah, kind of weird, isn't it? Because two forwards? Olé. Did I really not use a variable argument for that? So it should be at 0 minus 1 now. Yeah. Because it doesn't cancel the execution of the next command. That sucks, huh? So that means that we need to interrupt this, or no. I guess interrupt this. Our beautiful fold. And then this is something I also still want to refactor. I wonder if there's something like method composition in Kotlin as well. For functions or something. Oh, there you go. Hmm. So I'm just looking for a way to do composition, I think. Yeah. Okay, so what I'm sort of reading is that you can do that. But it's gonna be a pain in the butt. Mm-hmm. Mm-hmm. I guess I'll read this. Oh shit. Okay, I'll check that out later because that's the answer to this. Then you can just first compose all of these and then end up with a final position. Or do you? I also need this one. So we'll end up with this one. And oh, you need both. You need both. Oh, Shechial. I need both the message and the wrapped, but the wrapped is also the obstacle position. Anyway, think about that later. Now our tests are still failing, right? Because it's not executing. I mean, it's still executing, excuse me, the backwards command. So what we need to do is, instead of just simply returning this rover, or well, actually returning this rover back here, we need to check whether or not our rover's message or something is stuck, or if it has a message. Because if it has a message, then we found an obstacle, right? And then let's do this. Convert reference to lambda. It's exactly what I wanted to do. And now I need to check if my rover has a message. Then that means it's our position, or I mean, there is an obstacle, right? So if there is an obstacle, then I just want to return the rover. Otherwise, return this result. And then it'll just keep on passing. It will try and execute all of the commands, but it won't stop executing it. So I mean, it won't stop the loop, but it will stop doing this. So I think this should work now, actually. Yeah. Let's make a little commit. When it doesn't process other commands. Does this mean that our scenario test also works? Let's run them all. No! Why is that? What? Even this one fails. Why is that? Because Mars doesn't have any obstacles. See, it's an empty list. There's something wrong there, for sure. Fishow. See, I expected it to be at 1 and 2, and instead it's still facing north. And it only moved up once. What? And the other tests are working. Where? Let's look at these. What am I missing here? The rotates. It's the rotates. The rotate also shouldn't do anything, because I only add messages when I'm moving. That's why. Actually, once a message is being set, it should remain on your rover. Man, I need a state pattern for Kotlin. Like something that tells me I only want to change these values, but actually return a new rover. So a rover upon receiving forwards, then left should keep facing north. Facing north. There we go. So position, I don't care about. Direction should remain north. Allez. So same. And then this test is going to fail. What? Ah. And it has the moment it has a message, then you stop receiving commands. Well, what the hell is the issue then? Okay, let's just enable our debug method again. And then rerun just this test. And then see what is going on. What? If it's not null, return the rover. Otherwise, receive command. Only forwards gets processed somehow. Or is this yeah, nee. So how come I can't reproduce it in the other test? Because I'm just doing forwards and left. Because it's actually okay. Hang on. Because north is the default. No. Now I'm just guessing. Just write another test. Rover facing east. Should keep on facing east. Problem. And then so first it will be facing east, but there is an obstacle there. So if you receive forwards and then left, it should keep facing east. And still remain at 0, 0. Let's check this one. Wadu heck. Hang on. Forwards, forwards, left. Then this one should fail, right? And then we'll put this one here. 2 spaces. Should be facing east. Ya bastard. And your position should be 1, 0. What? Yeah. And failing test. Come on. Help! Help me, please. Why is it only executing one forwards? Yeah, no, it makes sense. Dude, I do not understand why it just keeps on executing one command. Hey, wait. It shouldn't be. Oh. There you go. See, this doesn't not make any sense, right? I expected it to be forwards, left, right, and then stop processing. Instead, now it just stops processing at a single executed statement. But I need to be able to write one unit test for this. Like, why? How can I do that? I could go forwards 3 times forwards. Get rid of this. Where we put this one on 3, which would wrap. God damn it. Aha. Oh yeah. Y should be 2. Oops. Ah! Yeah. Phew! Okay, now we need to figure like why is because I have other tests executing multiple commands. The twice. But all of these is manual. Shit. Okay, so I am going to change all of this into receive command the with this. Okay, I'm going to make an overloaded method. Commands, and you can go like var arg, yarl varg command returns a rover equals receive commands with a list of commands. Okay, how do you do that? As list, to list. Ja. Nee. What's the problem? Wait, what? Ah, so var arg makes it into an array or something, and then you can do to list. Yeah! Yay! Now this works. Great. And then the same for these. Ooh. Okay, same for these. Wait. There we go. Do I have anywhere else where I go like receive command, receive command, receive command? Guess not. And then all of the... no. No! Okay. There we go. Okay, now let's see a bunch of tests fail, huh? Yes! Okay, we knew about that one already. There we go. Alright, cool. So what the hell is the problem with this thing? I just do not understand. So let's see, huh? We get a bunch of commands. We will loop all of those commands. We will pass those commands onto a lambda that takes in both the initial rover, which has no message. It has no message. And then, for example, the forwards command. We come across this condition. We check, hey, does the rover that got passed into this thing, does it have a message? So initially, our default rover has no message. Then is it different from no message? Yes. Equals null. Let's do it the other way around. So if it has no message, there you go. If it has no message, then receive the command and then return that. Ah. Nee. Because this is the thing that returns the accumulator, right? This function. And that will be the rover with the applied move command. We'll enter here. I'm so puzzled. Let's just take one, run it in debug mode. Okay, let's check these commands. Forward, left. First thing, you ass. What the hell? Oh, is there an... Hmm. Wadu. This is the same, right? Same code. Allez, without checking for the message. Uh-huh. I guess something I could do is this. If message. We can just write it somewhere else, right? If message equals null, actually perform something. And else return this. And then we flip this. And then we run this. Same result. I am so confused. How is that different? How is that different? Let's put the marker here. WTF. And then later I can check what actually went wrong, or the stuff that I was missing. How is it? How is it different? How? Please tell me how. Yeah, so now if I run all of the tests, it should work. I'm just mightily confused. What about the rest of the tests? Okay, still one of them fails. Which one is that? Allez. A default rover receives a bunch of commands of which the middle one would cause the rover to crash into an obstacle. This is unwrapping. And so what's the issue, my dear friend? What is the issue? Oh, the message. Okay. So it actually works. Just needed to check this message. And now everything works. And now let's put that is equal to a rover that has facing direction. That's planet. And that has a message. Great. Where's my GG button? Let's disable the command list as well. I mean a debug statement. Yeah, this is the thing I wanted to. This is now finished for real. Running into an obstacle. Yeah, it doesn't process other commands. There you go. And that's actually that. Hallelujah, France. We did it. Final requirement. All right, let's look at what we have. So we've got a rover that is able to receive a bunch of commands. This transforms the variable arguments to a list so that I can then fold over that list and execute the commands in that list one by one on a rover. This receive command necessarily needs to return a rover. Oh boy. Sorry about those messages. I need to turn off notifications in the future. Let's add that to the checklist. Disable SMS notifications. There we go. So receiving a command can either be a move or a rotate command. Is handled by the respecting methods. Rotate just checks whether or not we're rotating right or left, just clockwise, counterclockwise, and then returns a new rover. Note here that I'm not actually returning the message, but I can't write a failing test for that, I don't think. So then we'll move into the move command, and then moving does a sequence of trying or attempts, basically. The first attempt is just try to move. What would your new position be according to your moving direction? So this is the actual move command. Then some special cases like if you'd be at an edge of the map and you or if you are at the edge of the map and then you would move across its boundary, you would end up on the opposite side. That's this method. Then we would check for an obstacle, whether or not wherever we want to go, whether or not it's wrapped. We want to go. We want to check if there's an obstacle there. If there's an obstacle there, just stop where you are right now. Otherwise, actually move there. And then return that rover. Then the other thing that we did as well is within. Where does the message for? Ah, yeah, okay. So then the final thing we did is check whether or not that we have an obstacle. Let's put that there. Message when obstacle. Like that. So then we also check for an obstacle and whether if there is an obstacle, then we map that obstacle's position to a string, and otherwise we return null if there is no obstacle. Okay, cool. And then to facilitate all of this stuff, we've got a planet that our Mars rover is knowledgeable about. And our planet knows about edges, throws exceptions when you're trying to go out of bounds. So that belongs to the API of the planet, right? And then, what else does it have? Yeah, it knows about its edges, whether or not you're on an edge and whether or not you're outside of an edge. And then how to wrap. That's it basically, and then some modifiers, or not modifiers, implementations of a planet where only Mars has obstacles. Yeah, that's about it. And then we did all that by writing unit tests, a whole slew of them, where here we've got all of the stuff about obstacles. Then here it's wrapping, I think. So here's obstacles. Wrapping, because this is all about edge stuff. Wrapping. This is just simply rotating. Oh, hang on. Rotating. And this is moving. Simple moves. In the correct direction. And then this is initialization. This is so that no teleportation has been invented. Same. And that's it. Cool. Let's make that our final commit. Cleanup. There we go. And then I am going to push that so you can follow along with what we did tonight, which is first reporting an obstacle, staying put when running into an obstacle, and then stop processing other commands. And then some cleanup. All right, I hope it was worth your time. Let's check what Koen has said. So yeah, indeed, I do have a delay. So Koen asks that there or notes that there is a delay on the messages that he's posting, and then the messages you're actually seeing, or like the time in between. This is a streaming delay, and it's there for me to use when I, for example, show my password by accident or something. Then I can immediately just stop the stream without you guys having seen it. Now there are other screens for that, like this one, for example. I should first click on this and then switch and actually fill in my password or whatever. But people are human, as you've seen today at my failing tests. Yeah. So there you go. Cool. Thanks for watching, and I hope to see you next time. Next time I'll be working. I can show that. Next time I will be working on this, which is an application or a hobby application, basically, where I want to try out a full Kotlin setup with Vue.js to build like a small application to facilitate a little game we played during Snowcase. Last year, actually. We didn't do it this year because we were too lazy to come up with good challenges, I guess. So I hope that this tool can make the challenge happen again. That's basically it. Alright, I'd love some feedback, so please hit me up on either Twitter or GitHub. Maybe log some issues. I'd like to know how you guys are doing with the katas, or whether or not you'd like me to try another kata, like Game of Life or whatever is on a catalog website. Just let me know. Maybe trying to do some constraints, maybe like baby steps, for example. That would be a fun thing to do. Yeah, that's it. All right. So until we see each other next time, I hope you guys have a great weekend. And yeah, that's it. That's me signing out. See you next time.